Hey everyone, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at Lesson 3 from Chapter 6, which is looking at adding and subtracting rational expressions. So how do you add or subtract simple fractions like 1/2 and 4/6? So our first step here would be to find a common denominator. So you want to look at what number can 6 and 2 divide into. And typically you want to find the lowest or smallest number that both of those numbers can divide into. And in this case here, that is 6. So we want to change this 1/2 to have a denominator of 6. And in order to do that, you have to multiply. So you multiply the bottom by 3. But you want to keep this fraction equivalent, so you have to do that to the top as well here. So what our fraction becomes is 3/6. And then our second fraction is already out of 6, so we don't actually have to change that. So that stays as 4/6. Once we have that common denominator, then we are going to add the numerators, and then the denominator stays the same. So you add 3 plus 4 is 7, and denominator stays the same, so it stays as 6. And then a step 3, and this is if this actually applies, is you can reduce this to the simplest form. And say in this case here, simplest form would be turn this into a mixed fraction, which would be 1 and 1/6. So we can apply these same rules to adding and subtracting rational expressions, although we need to make a note here. Generally, it's easier to add and subtract rational expressions with unlike denominators by finding something called your LCD, or your lowest common denominator. And that's actually exactly what we did in this little example here above. We found the smallest number that we can turn those two denominators into. So that's called your lowest common denominator. So the smallest number that you can write this denominator for. So the smallest number that these two numbers here have in common. So by finding your LCD, this really takes away from you having to reduce this step 3, I guess, in our list of steps. So it really kind of helps reduce or prevent you from having to reduce. So it kind of saves you some time in the long run. So we're going to look at an example from your notes, and this one here is example number 3. So here we're going to add and subtract the following rational expression, and then we're going to list all the possible or all the non-permissible values. And so just like before, even though it says to list all your non-permissible values afterwards, I always like to do it first, because then you're breaking down your denominators into those different factors. So it kind of helps keep your work in one little area, and so that way you're only working with one thing at a time. So it prevents clutter later on. So here we're looking at adding, so we just want to look at our denominators here. So what values would make that whole denominator equal to 0? So we have to consider both fractions. So our first one here is when we have p squared minus 1, and we want to set that equal to 0, so we find out all the values that would make that 0. So just like I've been talking about in the last few videos, so when you only have two terms, you really only have two options of how you can break down this p squared minus 1 into its factors. So either A, you could pull out a common factor, or B, it would be a difference of squares. So you cannot pull out a common factor out of p squared and 1, but what you would notice is that p squared and 1 are both perfect squares, and they're separated with a subtract symbol, meaning that this is a difference of squares. So you're going to draw your two brackets, and you square root your first term. So the square root of p squared is just p, so that goes on the left. Then you square root your last term. So square root of 1 is just 1, so that goes on to the right. And then 1 gets a plus sign, 1 gets a minus sign. And then set it equal to 0. Then from there, we're going to set each of those factors equal to 0. So we'll start with our first one here as p plus 1. And so here we're going to subtract 1, because we want to get p by itself. So p cannot equal to -1. Then looking at our second factor, we have p minus 1. Set that equal to 0. We want to get rid of the subtract 1, so we want to add 1. So if here we have p cannot equal to positive 1. So now we're all done with that first fraction, so now we can look at the second one. And so this one here is pretty nice. We just have p plus 1. So set that one equal to 0. And this one here is already broken down into its simplest factors there. So here we just have to solve for p. So you're going to subtract 1 on each side. And what we find is that p cannot equal to negative 1. Then we can just write this as a simplified little statement here. So you could say that p cannot equal to. So here we have negative 1, 1. And then here we have negative 1, but we don't want to rewrite that because it's already listed in our little statement here. So here is a list of our non-permissible values. So p cannot equal to negative 1 and positive 1. And then once we've done that, we're ready to move on. Now we can actually simplify our rational expression. So I'm just going to rewrite our little fraction here. So we had 4 over p squared minus 1 plus 3 over p plus 1. So according to our first step, we had to find a common denominator. And so in order to find your common denominator, what you should do is first break the denominators into its different factors there. And we've already done the work for this. So p squared minus 1 can be rewritten as p plus 1 times p minus 1. And then our second fraction is already in its simplest, broken down to its different factors. So you don't actually have to do anything for that one. So then to find your LCD, or your lowest common denominator, you want to go through the list of your denominators here. So you're going to start with your first factor. If you don't see it in your list of LCDs, you need to write it there. So our first one here is p plus 1. Then our next one here is p minus 1. Then we go over to our next one. We have p plus 1, but that's already in our list, so we don't need to write that again, because then that wouldn't be our LCD. So then what you want to do is you want your denominators to look like this. So you want p plus 1 times p minus 1. So your first fraction is actually already in that form. That's awesome. But in our second fraction, here we only have the p plus 1. So we only have this first part of that LCD. So what we need to do then is multiply it by that missing factor. So multiply this by p minus 1. And then remember, just like what we did in the beginning of this video, you want to keep this expression equivalent. So what you do to the bottom, you have to do to the top. So you times the top, or your numerator, by p minus 1. So we have 4 over p plus 1 times p minus 1 plus, so here we have 3 times p minus 1 all over p plus 1 times p minus 1. Now that we have common denominators, now we can add the numerators and the denominator stays the same. So what we really have here is 4 plus 3 times p minus 1 all over p plus 1 times p minus 1. So now that we've technically added our fractions, what we now need to do is we need to make sure that this is in our simplest forms. And so what we have to do is we have to distribute this 3, or what I call shooting your arrows. So you have to distribute that 3 inside your brackets and then see if you can collect any like terms. So you have 4 plus, so you have 3 times p is 3p. then 3 times -1 is -3. And then we'll just leave our denominator as it is, as p plus 1 times p minus 1. And then we can add those like terms. So here we have 4 and -3, or 4 and subtract 3. So 4 minus 3 is positive 1, plus 3p is all over p minus 1, or p plus 1 times p minus 1. Then what you should do is always double check. Ask yourself if you can simplify this numerator to make it look like any one of these little denominator factors. And in this case here, we're actually all done because we can't remove a common factor of 3 because this here is only a 1. So you'd be left with, say, 1 over 3, which wouldn't do you any good. So at this point here, we're actually all done. So we've added our 2 rational expressions, and we've listed those non-permissible values. So that's everything here for this video. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.